we need to understand those special purpose address. For example, some of the address are being used for broadcasting. Also, we need to aware that we would have a problem such as multi-home host. Then how we handle this kind of scenario. Okay. Also, we need to aware that there are certain kind of routine that we would use the first address within a block to represent the network, and that address will not assigned to a host. Okay. In chapter 5, we talk about how to mapping internet address, which is a logical address, to a physical address or hardware address. And in this chapter, we need to understand how the ARP protocol works. I mean the implementation. For example, we need to understand it will, when we try to send a packet over the network, it will first send out request. After they got receive the response, then we would have some kind of bounding established between the physical address and logical address or IP address. We need to aware of some kind of timeout for ARP packets. And we also need to aware that ARP would be encapsulated in a data frame and being shipped out in some kind of broadcast over the network. In chapter 6, we talk about IP, which is a connectionless delivery system. In this chapter, we need to understand the basic concept behind IP. Okay, IP would use some kind of IP datagram, have a header and a payload, or the data section. We should be able to identify the key elements here within the header. Okay, for example, the header length and type of service and the total length, etc. As we know that for the basic element for IPv4 header, there will be 20 bytes. We can have additional or optional field, but we are at least to have the basic information, which would have about 20 bytes. And we, for example, here with the information of a header, we need to identify this one. Here is a version 4, IPv4, and the header length with 5 times 4 bytes, which is 20 bytes long. Okay. And we also need to aware that the datagram fragmentation, because each network node, the equipment there, would have MTU, maximum transmission unit, limits. Not all the large packets can be put through certain equipment. router switches along the path. So sooner or later, they have to be chopped into smaller pieces. We call fragmentation, and we need to aware of how to fragment the data. And eventually, we have to reassemble it. Normally, we would reassemble it at a final destination instead of along the path at certain point. Also, in order to avoid loop problem over the internet, what is loop? Well, loop would be the case that the packets will circle around certain among certain routers and never reach the final destination. That will be the situation we do not want to have, so we have to take certain measure to break it. Time to live or TTL field in the datagram header would be the option, which means that every time we have packets pass through one hop or one router, the TTL field would deduct 1. Once TTL equals 0, the packets will be dropped. And also we need to aware that there are certain kind of application for us to utilize TTL for special purpose, such as the ping and the trace route. They would help us to identify the hops a packet, certain packets have to go through before they reach the final destination. It would be a very useful tool for us in troubleshooting. In Chapter 7, we need to focus on how the datagram are being forwarded, or just say that how each router would treat incoming packets, how the routing table are being established and maintained. Also, we need to understand the basic concept or the algorithm for forwarding datagram, which we can find out on the textbook on page 101 in figure 7.3. Means that we need to know how the router would handle the incoming packets in different kind of scenario. Well, for instance, we might have a question like this. Here we have a routing table on certain router. Here is route R. We might be able to say that give you a certain kind of elements. Then you need to fill out some blanks here. Okay, just try to go over this example and see how the routing table are they being established in order to reach certain destination. Then what will be the next hop address that would be filled in on this routing table. In Chapter 8, we discussed about ICMP. We know that we need to have some kind of mechanism to handle the error. Okay, ICMP is one of the error reporting and detection protocol that will help us to identify the problem over the network. For instance, certain destination is